that this was back in 1-2, and some of these words, domain, range, asymptotes, we're going to get to holes and that kind of stuff in this same section just a little bit later. Well, I mean, those were not very nice words to you. You didn't particularly care for that, but I'm hoping that as we go through this is the second time around, and that we can start seeing the connections. We can start seeing how this relates to this, and look at it graphically and through the table and algebraically, and bring that stuff in, and a light bulb will go, aha, I see how that relates to this, and blah, 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 blah. So what I want you to do first is let's look at our restrictions. We want to head for domain. Do I have any restrictions here? What can x not be?
-2.
Okay, so I know that x cannot be -2 because if I plug 2 in, -2 in for x, my denominator becomes 0. Can I divide by 0? Nope. Not now, not then, not tomorrow, never. Okay, I can't divide by 0. So therefore x cannot be 2. All right, what I want you to do is grab your calculator. We're going to be using the graph to verify, to double check, so that we can visually see it through the graph, and then also we have done it algebraically as well. So get this 2, and don't forget that if there's more than one term, we must have parentheses to get it correctly into our calculator. So we're going to take 2 divided by x plus 2. And a fairly basic graph that we've seen in pre-calc, okay? Very basic. Now, just remembering, as we go through this, that domain is my x value, okay? Domain is my x, range is my y, domain is my x value, domain is my input, y is my output, y is my range. All of that interconnects, okay? So if my restriction is -2, that means x cannot be -2. Since I'm referring to x, that means I'm referring to domain. So if I have a restriction of -2, it can't be -2. My domain goes from -infinity to -2, union with -2 to infinity. So once I find my restrictions, I have automatically then found my domain. And we're writing it in interval notation from -infinity to infinity. We always write it from least to greatest, just as if it was going along a number line. Okay, so that's my domain. Does that make sense looking at my graph? I go from -infinity here to the far left. Does it look like that there's a break at -2? It does. There's nothing there. So no matter how high up, when x is -2, I will never have a number for a y value. And as I go down, -2, there will never be a negative y value either, okay? Because of that, watch my pencil. Actually, I'm lying. It's a Sharpie pen. Watch my Sharpie pen. What am I invisibly drawing right here? What kind of an asymptote? Okay. Stay with me here. Algebraically, we found a restriction. Was that very hard to do that? No. Once I say that, we just set that equal to 0, saying it can't be. We cannot have a 0 in the denominator, so we say x plus 2 cannot equal 0. That's where that came from. I automatically found my domain, and then I automatically found my vertical asymptote. All from that little restriction. Okay? So those 3 connect. Those 3 connect. All right, now I move to range. We're going to play fill in the blank. Unless my function is a blank function, I must graph it to find range. Unless my function is a blank function, I must graph it to find range. What kind of function can I solve for range without having to graph? Dun, dun. You're on the right track, but it's not linear. Quadratic. quadratic, because quadratic I can find a vertex, either a minimum or a maximum, so therefore my range either goes up to that far or goes down to that far. So that's why I can use an algebraic method only if it's a quadratic. But is this a quadratic? No. Therefore we graph it to look at range. Okay, so I bring my graph back up. Range again is my y value, up and down. And so it's like little Mario guy walking along the y-axis, do. And whenever there's not a graph, he has to make his little jump. All right? So does this graph cross does it visibly look like it crosses the x-axis? No. So it looks like I might have a little issue here. So where's my break for my range? At 0, because the x-axis is 0. Okay? So I write my range. I can go from negative infinity, which is down below, up to 0. Then we make our little jump. And then I continue on. And remember, I'm using parentheses because does that mean 0 is included or not included? Not included. Okay? If I wanted 0 to be included, that parenthesis would turn into a bracket. Good job. Good job. Okay. Now, there are 1, 2, 3, 4 in here, I do believe, that are going to say, what is she talking about? Okay? But that's okay. Horizontal asymptote. Horizontal asymptote. What's the crazy little thing that we learned about horizontal asymptote? What's that acronym? See? Say what? This will be the best thing that you have ever learned in your entire life.
Wait, what is it?
Bobo Botten eats DC. This has to do with my horizontal asymptotes. Okay? Horizontal asymptotes. That's kind of sloppy, but horizontal asymptotes, Bobo Botten eats DC. So what I look at when I'm looking at my horizontal asymptote, I'm looking at the exponents. Okay? So I go back to my function, h of x, I look at my function. My degree, I'm looking at my degree. What's the degree of the numerator here? If there is no exponent, or excuse me, if there is no variable, what is my degree? 0. Stay with me. X, anything raised to the 0 power is what? 1. Okay? So that's 2 times 1, which is just 2. So my degree here is 0. What's my degree down here? 1. It's not shown, but there's my variable. So it's just 1. Okay? So which has the bigger degree? 0 or 1? 1. So I am...
Variables?
Huh?
It only works for variables?
Degree is only on the variable.
Okay.
Degree is only on the variable.
Okay.
Yep, good, very good question. Okay, degree is only on the variable. This would be a coefficient. That 2 would be the same thing as saying 2 times x to the 0 power. X to the 0 power is 1. So 2 times 1. All right, so I am big on bottom. Big on bottom. So I have a horizontal asymptote at 0. That's what the Bobo means. Big on bottom, horizontal asymptote at 0. So horizontal asymptote at y equals 0. Now wait a minute. Where else did I see 0? Where else did I see 0? In my range. I had a break at 0. So once I find my range, I find my horizontal asymptote. Once I find my horizontal asymptote, I found my range. So maybe Bobo Botten is a little bit easier to use for horizontal asymptote, and then you can work back to your range. You know, whatever works. Okay? So that's y equals 0. Now, what else ties into my horizontal asymptote?
Behavior?
Oh, good.
Thanks.
My in behavior. Okay, now stay with me here. I had some people say, I still don't get in behavior. Okay, this is a simple graph to look at. In behavior, actually, let me write it out so we can see the notation. So the limit of the function as x approaches negative infinity is something. Limit of the function as x approaches infinity is something. Okay? So I'm going to fill in those spots. That notation stays the same every single time. Okay? This notation stays the same every single time. The limit of the function just is a boundary. Okay? It's like, what the heck's going on? The x approaching negative infinity and the x approaching infinity is direction. So that means, bless you, if I start at the origin, so I'm like going from the origin out. Okay, I'm starting at the origin and I'm moving out. So if I start at the origin, as x approaches negative infinity, it means to the left of the y-axis. So as the graph goes from here on out to infinity, and I'm going to use the word arrow, like the end of the graph, which way is the arrow pointing? If this arrow on the end, that's invisible arrow, we're going to pretend that is there. If it's pointing up, it would be going to infinity, positive infinity. If this graph was pointing down at the end, it would be going to, but it's not. It's not going up, it's not going down, it's pointing off to the left. So we use our horizontal asymptote to represent that in behavior. So that horizontal asymptote is, that's why we put 0 right there. Same thing to the right-hand side. As we go from the origin off to the right, if this part of the graph, if this arrow was pointing up, I'd have positive infinity. If it was pointing down, I'd have negative infinity. It's not. It's pointing off to the right-hand side. Therefore, I utilized my horizontal asymptote, and we said my horizontal asymptote was Zippo.
So is it kind of like saying, as x goes to negative infinity, what is y doing?
It's exactly what it's saying.
Okay.
What is the graph doing? What is y doing? What is the function doing as x goes to negative infinity? That is exactly it. Yep.
So
perfect.
if the graph was like that, then as an x approach negative infinity, it'd be going to
Negative infinity. Uh-huh.
Okay.
Uh-huh. That's in behavior. Brad. Okay. Asymptotic behavior. You're going to see this several times throughout. We in regular pre-calc are not working with asymptotic behavior, so cross that off. Okay. Now we go to our y and x intercepts. This is something that you've been dealing with since you learned how to graph. Okay, where does it cross the x-axis? Where does it cross the y-axis? If it's not visible on here to where you can tell without a doubt, this is pretty clear. Looks like that I cross at y equals 1. Okay, that's pretty clear. But you know what? I don't want to assume, so let's go to my table. When x is 0, that's going to give me my y-intercept. When x is 0, what's y? 1. So that verified it actually did cross at 1. Then my x-intercept, I'm not as for sure on. Let me go back to my graph. But wait a second. How come I know that there's not an x-intercept? Because I have a horizontal asymptote there, absolutely. So there is no x-intercept on that at all. Okay, there is no x-intercept on there at all. Okay, questions, comments on any of those definitions or characteristics of the graph that we've seen back in section 1-2 that we're now touching back on in 2-6? Domain, range, asymptotes, in behavior, or intercepts. Okay, let's throw in this next one. What I want you to do is go ahead and put this into your calculator, but you're going to have to watch out for those double parentheses as you type that into your graphing calculator, making sure that there's a parenthesis out in front of 2, double parenthesis at the end of 3, and the same thing for the denominator as well. So we type this in. And you should get a interesting looking graph. How many of you, and I'm going to say this not to be a judgmental statement whatsoever, but just out of curiosity, how many of you in here are firstborn children? Firstborn. The only one. So you get to raise your hand on all of these questions. How many of you guys are the middle child? Okay? And I'm going to be referring to the middle child quite a bit in this next little piece of this lesson. How many of you guys are the baby? That's my hand. Okay? The baby. All right. We kind of have that situation going on here. We've got our oldest. We've got our middle child here that kind of throws things for a loop. And then we have our baby that's, kind of hanging out down here, kind of doing its own thing as well, okay? All right, so looking at this graph, we've got an interesting thing going on. Hallie?
I think I put it in right, but it's like wrong. Did you do parentheses like over the entire thing? Yeah. On the bottom too.
Make sure that it's not over the numerator and denominator. Numerators is its very own set of parentheses, denominators is very set.
Okay, that's my
Check that, okay? So, just looking at this algebraically, what are my restrictions for this function? What can x not equal? Negative 1, negative 5. X cannot be negative 1, x cannot be negative 5. So therefore, that leads me straight into my domain. And again, writing my domain, I write it from least to greatest. Which is larger? Negative 1 or negative 5?
Negative 1 is larger.
Negative 1 is larger, so I'm going to write that. Worded that kind of weird. Okay, so I go from negative infinity to negative 5, union with, because there's a break. Negative 5 to negative 1, union with, negative 1 to infinity. Each break represents a what? When it deals with domain, each of these breaks is a what?
Asymptote?
It's a vertical asymptote. Okay, so that leads right into my vertical asymptotes. Okay, now let's look at my range. Just looking at the graph, because I don't have a quadratic to solve that, so let's look at my graph. It's kind of funky. What trumps what here? I mean, like, which piece of this graph should I really be looking at? Great thought. Looking at the outer two. On part of it, I will be. But the range, I get to go into the middle part. So if I would look at my table, I have a value all the way through for, well, I would have a value everywhere for my y, which is my range. If I have a middle piece in my graph, this is just something to tuck away in your little noggin. If I have a middle piece in my graph like this, I can utilize that middle piece for my range. So does it look like that there's a break at all in this middle piece? No. So therefore, my range includes all real numbers because of the middle piece. Okay, it's the middle section of that graph. Now, going back to the graph, no. Does it look like there's a horizontal asymptote? Or totes? Yeah, it does. Okay, it does. Let's see if we can support that algebraically. I know. Winking, quiet. I'm trying to video in here. Does it look like there's a horizontal asymptote? So let's look at my degrees. So this is x times x, so I have numerator, x squared, denominator x times x, x squared. So what do you know about my degree here? Exponents are the same. So I'm at my eats DC. So exponents are the same Therefore, I divide my coefficients.
Pre-calc knows asymptote, right?
Mhm. So if they're the same, so I'm going to divide my coefficients. So I'm going to take 2 divided by 1. So I have a horizontal asymptote at 2. So that's my eats DC part of the boba button.
Wait,
So-
so you-
So 2 divided by 1. Okay? I'm getting rid of my asymptotic behavior here. My in behavior, since I have a horizontal asymptote, I can easily fill that in. And if I look at it graphically, that should make sense. That as x moves to the left, the graph is approaching 2. As x moves to the right, the graph, the function, is also approaching 2. Okay, as my in behavior. Hmm?
Do you have 2?
You can. Well, we're going to see that too.
Wait, so why aren't we doing asymptotic behavior?
We did not go into vertical asymptotic behavior in regular what class are we in, pre-calc? We did not do that. We have to, in order to get through going at a slower pace, we have to cut some things out, and that was something that we cut out. And that is because it's not used a lot in calculus. So that's why. Okay, so Y-intercept. So I go to my table. When x is 0, what is my y value? And I hear you guys saying, and I'm going the wrong way. When x is 0, y is negative 3.6. Y'all see that there? Now, I want to come back to this real fast, but my x-intercepts, I think you can look at just graphically. I have x-intercepts at 3 and at negative 3. I can find that off the table and from the graph. That came from the table and algebraically.
Wait, if we backtrack just a little bit, for end behavior, did you say we can look at horizontal asymptote, right, to see that?
That's where it comes from.
Okay.
That's exactly where it
Okay,
comes
good,
from.
because I have trouble
Yeah.
looking at the graph.
That's where it comes from. Okay, now stay with me. Here's one more piece that I want to hopefully that you see tying together. When I'm looking for my y-intercept, because looking at it graphically, negative 3.6, I don't think anybody in here has the eye to be able to determine, oh yeah, that's at 3.6. So we did look at the table, but let's say we don't have a calculator. I'm saying a no calculator quiz. How do I find the y-intercept then? If my x is 0 for a y-intercept, if my x is 0 for my y-intercept, what would my, did I say x or did I say y?
You said X.
If my x is 0, how can I find my y? Absolutely. If you plug in your x, remember x is your domain, x is your input. If you plug in x as 0, what comes out? My y, my range, my output. So if I would plug in, and this would be a great question to ask. If I plugged in 0, guess what that equation would equal? Negative 3.6. So you could do that algebraically
That'd be
as
a
well.
bit of a difficult test one to get to.
Do what?
It'd be a difficult test one to get to.
It would be on that. Okay, now, all of this 100% has been reviewed. So what I want you to do for tomorrow, do not negate this. Do not neglect this.